China doesn't sleep. While the rest of the world debates, plans, and pitches ideas in boardrooms, China already has the machines running, the ground staked out, and the engineers on site. The pace at which this country reshapes its landscape and infrastructure has no parallel in modern construction history. This isn't hype from the headlines or some propaganda spin. It's a verifiable fact, measured in miles of tunnels bored, tons of earth moved, and bridges spanning gorges that a generation ago seemed impossible to cross. And behind every one of those feats is machinery. Machinery on a scale, with a sophistication and operational power that's hard to wrap your head around until you see the stats. In this video, we're going to break down 10 of the most mind-blowing machines China is using to literally reshape the planet's geography. From dredgers that rework the ocean floor to tunnel borers that slice through mountains like butter. Each of these beasts is a testament to human ingenuity pushed to the edge of what's possible. And the one at the top of the list is why you're watching this. Number 10. Cutter suction dredgers are one of those pieces of equipment most people have never seen in action, but their work shapes the coastlines of much of the modern world. These massive floating rigs are key to large-scale dredging projects, and China is now one of the biggest manufacturers and operators of this gear worldwide. A prime example is the CSD-450, a cutter suction dredger that's not made exclusively in China, but is often produced there and widely used in all kinds of water-based infrastructure jobs. Up front, there's a rotating cutter head with teeth built to rip through bottom material, whether it's soft sediment, packed clay, or partially broken rock. The head spins and shreds the substrate, while a suction pump vacuums up the broken bits, along with water, and pipes it through floating lines to a dump site that could be miles away. Typical working depth is around 40 feet, though specialized setups let them go quite a bit deeper. What makes these dredgers especially valuable is how versatile they are, building ports and docks, maintaining river channels, expanding shorelines, creating artificial islands, restoring aquatic ecosystems, and even underwater mining. They're machines that quietly redesign the boundary between land and water at dozens of spots around the globe, all at once. Number 9. If the dredger rules the water. The next machine on our list dominates on land with a mechanical brute force that makes it one of the most imposing tools in modern construction. The Sanya SR360 rotary drilling rig is one of the largest drilling units made in China, tipping the scales at about 130 tons and capable of boring piles over 300 feet deep with diameters up to 8 feet. When you're building a skyscraper, a massive bridge, or a major tunnel, the foundations sink deep into the ground via piles driven dozens of yards down to bedrock. Creating those piles starts with drilling the hole where the concrete gets poured. And that's exactly what the SR360 does. Its geological versatility is one of its most prized features. On a single job site, you might hit layers of soft soil, compacted clay, gravel, and rock zones that all demand different techniques. And the SR360 is built to handle that mix without swapping in a different machine for each condition, making it an incredibly efficient asset on projects where every hour on the clock has serious dollar value. Number 8. There are objects in the world so huge they can't be shipped the usual way. Deep water oil platforms are the classic example. To move these kinds of structures, there's a specialized class of vessel that blends the cargo capacity of a freighter with one unique trick: the ability to partially sink itself. The Zhenhua 25 is one of the most capable semi-submersible ships operated by China. The vessel is fitted with up to 3 heavy-lift cranes, each able to hoist up to 3,000 tons. But the real game-changer isn't the cranes. It's the ballast system. When it needs to load a structure that can't be lifted, the Zhenhua 25 floods its own ballast compartments on purpose, sinking in a controlled way until its deck is underwater. The structure to be transported floats right over that submerged deck. Then the process reverses. The ballast water gets pumped out, the ship rises slowly, and the structure ends up resting on the deck without a single crane touch. It's a mechanically elegant solution that's almost counterintuitive until you get the physics behind it. Number 7. In the realm of major underground works, road header machines, known by the German abbreviation EBZ, hold a unique spot that sets them apart from both massive shield tunnel borers and standard drilling setups. China has become the global leader in manufacturing this type of equipment. What defines an EBZ isn't just its size, but how it attacks the ground. They're outfitted with cutter heads designed for rock of varying hardness, and advancing on the excavation face with precision that shapes the tunnel to the exact profile the design calls for. Their modular architecture is a huge plus. Components can be tweaked or swapped based on the geology encountered during progress, without pulling the whole machine out of the tunnel. Advanced speed typically runs between 25 and 40 feet per day, depending on the material's toughness. The latest models are also built to cut down on waste volume during digging, processing material more efficiently, and reducing environmental impact, which makes them the go-to choice for projects needing cleaner, more controlled excavation. Number 6. Tower cranes are the tools of verticality in modern building. Without them, skyscrapers just wouldn't exist. And in that category, the Zoomlion R272 has set a new benchmark that until recently seemed out of reach. With a lifting capacity of 720 tons and an operating height up to 1,300 feet, this Chinese crane isn't just the biggest of its kind in the world. It redefines what a tower crane can do. To put that capacity in perspective, 720 tons is roughly the weight of 500 compact cars hoisted to the top of a 130-story building. Its smart control systems monitor load conditions, wind speed, and the crane's structural status in real time, constantly calculating safe operating limits. The biggest tech leap is its mobile counterweight system. In traditional cranes, the counterweight is fixed. On the R272, it can shift along the rear arm based on dynamic calculations that optimize balance for every position and load weight, delivering over 60% better lifting performance than previous generation designs. Number 5. Some machines wow you with their height, others with their length, and others with what they can move in a single scoop. The WK-75 excavator falls into that last group. Standing 77 feet tall and weighing in at 2,000 tons, this electric cable excavator is one of the largest digging machines on the planet. The stat that defines its power is 98 cubic yards per bucketful. In real terms, the WK-75 can fill a heavy-duty mining truck with fewer than 3 scoops. In open-pit mining, where the business model boils down to how much material you can shift in how little time, that capacity translates straight to profits. Its sensor systems constantly check the condition of every critical part, and spotting wear and overload before they turn into breakdowns. Assisted automation calculates the ideal dig point and force to max out each bucket's volume without stressing the structure, blending unmatched raw power with a level of smarts that minimizes cost per ton moved. Number 4. The XGC-88000 redefines what's possible in the crawler mobile crane category. Developed in China and launched in 2013, it was built to outdo every comparable crane in every key metric. The result is a rig with a lifting capacity of about 4,000 tons and a max working height close to 360 feet. 4,000 tons is the weight of over 2,000 mid-size cars. Power comes from 3 engines, each putting out 860 horsepower for a total of 2,580 horses. This machine moves slow and steady, which makes sense for something over 2,000 tons. But its ability to reposition on-site without full disassembly gives it serious operational flexibility. Its modular design lets it break into two main sections that ship and assemble separately, making it possible to get this colossal crane to remote spots where a fixed crane of similar capacity could never go. Number 3. China is the world's top exporter of goods, and the efficiency of its ports isn't a side note. It's a top-tier strategic factor. The automated container terminal at Beibu Gulf Port in Qinzhou represents one of the most significant leaps in port automation anywhere. The concept is straightforward to describe, but insanely complex to pull off. No direct human involvement in any container movement. The cranes are fully automatic. The vehicles hauling containers are self-driving. Slot assignments, sequencing for loading and unloading, and coordination across the whole system are handled by algorithms that process the status of every container, vehicle, and available spot in real time. The payoff is a handling capacity of about 10 million containers a year, equivalent to loading and unloading around 700 massive container ships annually, running steady 365 days a year. Number 2. The Taisun gantry crane, installed at the Yantai shipyard in China, is recognized as the world's most powerful active gantry crane. Its lifting capacity tops 20,000 tons, the weight of over 3,300 adult African elephants, up to 260 feet high. The crane's structure itself stands 436 feet tall by 394 feet wide, making it a skyline-dominating architectural feature at the yard even when idle. The cable system that pulls off those lifts totals nearly 30 miles long. Since its debut in 2008, the Taisun has enabled projects that used to need multiple on-site assembly phases, simply because no gear existed to move them as whole units. The control tech overseeing every operation ensures that any deviation from safe parameters triggers automatic corrections, making runs with this almost unfathomable machine systematically safe. Number 1. We've reached the main reason you're watching this video. The machine topping the list doesn't just earn that spot for being the biggest in its class. It earns it because it embodies decades of underground drilling engineering advancements applied to China's most ambitious project of its kind. The Guinness Book of World Records officially recognizes it as the world's largest shield tunnel boring machine. It's called the S880 Jingtian, and while its origins are German, it was built specifically for a Chinese project and represents the blend of European engineering precision with the large-scale infrastructure ambitions that define China in recent decades. The stats that define the S880 are these: shield diameter, 54 feet and 9 inches, big enough for a 5-story building to fit inside the tunnel it creates. Total weight, 4,850 tons. Length, including the installation train, 394 feet. Installed power, 5,600 kilowatts, equivalent to over 7,000 horsepower. The S880 was designed for the Tuen Mun Chek Lap Kok Tunnel project in Hong Kong, and a job linking the North Lantau Highway to the Tuen Mun area via an underground corridor that runs partly under the sea, with sections dipping up to 200 feet below the seabed. Subsidence limits on the surface are extremely tight because the areas above include existing urban infrastructure that can't be disturbed. Size isn't the goal here, it's a direct result of the project's needs. The tunnel has to be big enough for a multi-lane expressway with all its ventilation, lighting, and safety systems, and that diameter dictates the borer size required to build it. The S880's cutter head is fitted with dozens of disc cutters and picks arranged across its face to maximize efficiency against the ground. When this head rotates against the excavation face, it breaks up the rock in a controlled way. The material drops to the bottom of the head, where a paddle system scoops it up and dumps it onto a conveyor belt that hauls it back through the machine for removal. Behind the head, the nearly 56-foot diameter steel shield holds the surrounding ground in check, while the tunnel interior still lacks permanent lining. Inside the shield, the erector system installs precast concrete rings that form the final lining. Each ring is made of several segments that the erector positions and tightens to create a circular structure, tough enough to withstand lateral ground pressure and, in underwater sections, the hydrostatic pressure from the water above. The S-8800's advance rate on the Hong Kong project was about 100 feet per day in good conditions. 100 feet a day might sound modest, but consider what's happening in every foot. The head bores. Material gets extracted. The shield pushes forward. The erector installs the next lining ring. Injection systems fill the gap between the lining and ground with grout to lock the ring in place. Sensors check alignment, and the cycle repeats, all in total confinement, 200 feet under the sea, with external pressures that could turn any glitch into an emergency. Operating parameters are constantly monitored and tweaked to keep the machine optimized for the ground it hits at every stage. Because the ground isn't uniform, it can shift from one foot to the next, from sand to gravel, gravel to soft rock to a hard boulder that demands slowing down and ramping up cutter pressure. The S-880 is built to detect those shifts and adapt without stopping more than absolutely needed. This machine's impact goes beyond the specific job it was built for. Every tunnel project like this generates knowledge that feeds into the next design generation. Solutions for the unique geological challenges in the Hong Kong tunnel, tweaks to control systems for better performance, lessons on cutter head component durability. All that know-how flows back to engineers and manufacturers, becoming a competitive edge for future jobs. It's why China has caught up to, and in some ways surpassed, more seasoned competitors in a relatively short time. It doesn't just buy machinery, it learns from it, adapts it, and develops its own versions incorporating those lessons. The world underground, the world of transport tunnels, undersea crossings, and rail corridors that punch through mountains instead of skirting them, is a world China is building at a speed unmatched anywhere else on the planet. And the S-880 Jingtian, with its Guinness record and nearly 56-foot diameter boring 200 feet under the sea, is the most tangible symbol of that shift. A nearly 5,000-ton machine, the length of a 30-story building on its side, pushing beneath the seabed, drilling rock with the persistence and precision of a tool applied on a geological scale. Every day leaving another 100 feet of permanent infrastructure where before there was nothing but earth, water, and pressure. That's what China is doing, not just dreaming up the infrastructure of the future, building it, foot by foot, ton by ton, with machines no one could have imagined possible just a generation ago.